So good day, sir. So we are the group of PIC Microcontroller to be presented by Julius Rolle, Prince Pangilinan, and Saimon Landayan. So let's start.
So what is PIC? PIC is also known as the Peripheral Interface Controller. It's also a microcontroller, which is the smallest microcontroller in the world, and programmed to execute large numbers of operations. A brief history of the PIC. It was developed by General Instrument last in 1975. In 1985, General Instrument converted their microelectronics division to microchip technology. By 1993, microchip technology launched the 8-bit PIC 16C84 with EEPROM. In 1998, microchip technology continues to develop new high-performance microcontrollers.
So the 8-bit PIC microcontroller is divided into the following four categories on the basis of internal architecture. So the first one is baseline PIC, which is the cheapest. Then next is the mid-range PIC. Next is enhanced mid-range PIC. Then the latest is the PIC 18. So as you can see on the graph, on the baseline PIC are the least complex PIC microcontrollers. These microcontrollers works on 12-bit instruction architecture, which means that the word size of instruction sets are of 12 bits for these controllers. So these are the smallest and cheapest PICs available with 6 to 40 pin packaging. The small size and low cost of baseline PIC replace the traditional ICs like 555, logic gates, and etc. Then the second is the mid-range PIC, which are based with 14-bit instruction architecture and are able to work up to 20 megahertz speeds. So these controllers are available with 8 to 40 pin packaging. These microcontrollers are available with different peripherals like ADC, PWM, OP amps, and different communication protocols like USART, SPI, and etc., which make them widely usable microcontrollers not only for industry but hobbies as well. Then next is enhanced mid-range PIC. These microcontrollers are enhanced version of mid-range core. Then this range of PIC also includes multiple peripherals, supports protocols like USART, SPI, I2C, and so on. Then the latest is the PIC 18, is on 16-bit instruction architecture incorporating advanced RISC architecture, which makes it highest performer among all of the PIC families. So the PIC 18 range is integrated with new age communication protocols like USB, CAN, LIN, and Ethernet to communicate with local and internet-based networks. So this range can also support connectivity to human interface devices like touch panels, etc. The PIC microcontrollers are available with different memory options like mass ROM, EEPROM, and flash memory. They are donated with different symbols as given in the following table. So as you can see in the following figure that the data memory is interfaced with an 8-bit bus, which means that it can only transmit or receive data with maximum of 8-bit data. While the program memory is interfaced with 16-bit bus, which means it can only store 16-bit program memory or instructions. The next. So as you can see, the difference of data memory and program memory. So program memory or ROM is used for permanent saving program being executed. while data memory, RAM, is used for temporarily storing and keeping intermediate results and variables. The next.
As you can see on the image, this is the latest PIC microcontroller, which is the PIC 18. The of it is architecture. It has the ALO, status register, and output, and special function register and general purpose register. And the next table is the pipelining of the PIC. As you can see, the PIC can fetch at the same time it can execute the previous fetch data. It has fetch example on this, the fetch one, and then the next cycle, it execute the fetch one at the same time it fetch the second data, and so on and so forth.
And for the advantages and disadvantages, so the basis of PIC microcontroller is RISC architecture thus operates faster. It offers easy interfacing of analog device. It exhibits lower power consumption. While the disadvantages is less number of instructions increases the length of the program. It holds only a single accumulator, and additionally, a single PIC can replace a wide variety of separate electronic components or circuits, increase the product reliability through the use of test components.
Oh, this guy, look at me right now, dude! Oh my god.
So PIC versus Arduino. So the PIC has a 8-pin structure. It comprises of EEPROM CCP system service processor program segment prefix, add with carrying segments, in circuit, serial programming, processor, and LCD. It operates on 5 volts to 6.6 volts. It is implemented in simple toys, control system, remote controls, power tools, and automatic engines. Multitasking, it operates as a strong and robust processor. It can only be used in ports of Ethernet, Wi-Fi, Bluetooth, audio, and video output, USB port, camera port, and other HDMI ports. Simple coding for functioning of electronics. Next. So for the pin configuration, there are 40 pins of this microcontroller IC. It consists of 2 8-bit and 16-bit timer. Capture and compare module serial ports, parallel ports, and 5 input outputs are also present. And then, so the PIC microcontroller has a number of 33 pins input output, and the CPU speed is 5 MIPS or 5 million instructions per sound. And that's all. That's all for our presentation.
That's it for our presentation, and we're gonna have a simple simulator for the PIC microcontroller. First, we're gonna use Micro C Pro for PIC software and Proteus for the simulator. First is we need to upload the code to the PIC using the Micro C Pro software. It's like the Arduino IDE, we need to code first, then upload the code to the Arduino. In here, we have simple program. It will turn on and off the LED. First is the configuration. You can see here that you need different config. These are default. And then include this xc.h. Then same as the Arduino IDE, almost in main, and then This B0. It is the RBO as in output pin. Then a while loop. And for the RBO, RB0 is equals to 1, which is the LED. The lights will be on. And then the delay underscore and then delay underscore ms, which is 1000, which is equals to 1 second. The same time, after that, set the RB0 to 0 to turn off the lights. Now to upload this to a PIC microcontroller, we need to start. Now we need to select the MCU family. We use the PIC on the Proteus. We use PIC 16F877A. So let's change this to 18F. Then let's locate the PIC. (16F8) 16F. 16F8 77A. And then save. Sample test. Then we go back to Proteus and then we're gonna load the file. And press OK. Yeah, as you can see, the lights on the simulator is turning on and off based on the program we upload using the Micro C Pro for BIC.
Yes.
That's it, sir. That's our report for the PIC Micro.
Thank you po, sir, for listening.
Thank you, sir. Good day.
Good day po.
Thank you, sir. Good day.